Have you ever wondered what's really happening beneath your car? There's a whole world of moving parts and hidden mechanisms just out of sight, working together every time you drive. Sure, you know about the engine, the gas tank, and the brakes. Those are the stars everyone talks about. But there's a hidden spinning rod under the floor that quietly connects it all, working tirelessly every time you hit the gas. It doesn't burn fuel or steer, but without it, your powerful engine is useless. All that horsepower would go nowhere. This is the drive shaft, the unsung hero of your car, often overlooked but absolutely essential. It spins at thousands of RPM, enduring relentless vibrations, twists, and the worst the road can throw at it, all while staying perfectly balanced. Most drivers never see it, but it's the vital link turning engine power into motion, making your car move forward. Think of it as your car's spinal cord, carrying the go command from the engine to the wheels, connecting everything in perfect harmony. It must be strong to handle massive torque, yet flexible enough for suspension movement. A true balancing act of engineering. The drive shaft is a marvel, refined over a century, and still crucial even in today's electric cars, adapting to new technologies while keeping its core job. Today we'll uncover its story, where it came from, how it works, and why it still matters in every vehicle on the road. Let's pull back the curtain and give this overlooked workhorse the credit it truly deserves. We'll explore its origins, its ingenious engineering, and its enduring role in every car, from classics to cutting-edge EVs. Ready to meet the drive shaft? Let's dive in and discover the secret world spinning just beneath your feet. The drive shaft's job is simple: transmit rotational power, but the way it does this is both fascinating and essential to how your car moves. It takes the engine's torque, or twisting force, and sends it from one place to another, acting as the crucial link in the drivetrain. In a classic front-engine rear-wheel drive car, the drive shaft connects the transmission to the rear differential, bridging the gap between the power source and the wheels. The engine creates power, the transmission manages and modifies it, and the drive shaft is responsible for delivering that power all the way to the wheels, making movement possible. But making this work is tricky. The drive shaft must connect a fixed transmission to a moving rear axle, which bounces and shifts as you drive. It has to flex, change length, and operate at different angles, all while spinning at high speeds and staying perfectly balanced, no matter the road conditions. If it's even slightly off balance, vibrations can shake the whole car, create noise, and even damage other components over time. A well-designed drive shaft works so smoothly and quietly, you forget it's even there, yet it's always hard at work beneath your feet. Whether your car has 50 or 1500 horsepower, or whether it's a sports car or a heavy-duty truck, the principle remains the same. It's a direct, reliable solution to getting power from here to there, a testament to solid engineering and clever design that stands the test of time. For over a century, the drive shaft has been making cars go, quietly powering generations of vehicles and keeping us all moving forward. The concept of a spinning shaft to transmit power predates cars by centuries. Old windmills and factories used line shafts to carry energy across buildings. Early cars borrowed from bicycles and industry, using chain drives to connect engines to wheels. Chains were simple and familiar, but exposed to mud, dust, and constant wear. They needed frequent maintenance and could break easily, leaving drivers stranded. As engines grew stronger, chains became heavy, noisy, and dangerous. Engineers looked to line shafts for inspiration. What if a solid, enclosed shaft replaced the chain? A shaft could be protected from the elements, run quieter, and handle more power. This idea marked a leap forward, transforming cars from motorized buggies into integrated machines. The shift from chain to shaft was revolutionary. It set the stage for the modern drive shaft. The era of the shaft drive had begun. Chain drives were messy, noisy, and high maintenance. Exposed to dirt and water, chains wore out fast and needed constant attention. As engines got stronger, chains had to be massive, heavy, expensive, and even dangerous if they broke. The shaft drive solved these problems elegantly. Enclosed in a tube, the shaft was protected and could run in an oil bath for long life. Maintenance dropped, reliability soared, and cars became quieter and smoother. The shaft drive made cars more accessible and sophisticated. By the 1910s, nearly every automaker had switched to shafts for all but the cheapest or heaviest vehicles. The drive shaft was here to stay. It turned the car into a true machine, not just a motorized carriage. Cleaner, quieter, and safer, the superiority was obvious. The automotive world had changed for good. The 1898 Panhard at Levassor pioneered the shaft drive layout we know today. Front engine, clutch, transmission, and shaft to the rear axle. This design moved cars beyond their buggy origins, but it introduced a new challenge, the angle problem. The transmission is fixed, but the rear axle moves with the suspension, forcing the drive shaft to pivot as the car drives. A rigid shaft would bind or break. Engineers needed a joint that could flex while spinning, a mechanical wrist. The answer lay in a centuries-old invention, the universal joint. This crucial component would unlock the full potential of the shaft drive. The universal joint, or Cardan joint, was described by Gerolamo Cardano in the 1500s. It lets a spinning shaft flex in multiple directions, perfect for cars. Two yokes and a cross-shaped spider allow the drive shaft to pivot up, down, left, and right while spinning. With a U-joint at each end, the drive shaft could handle all suspension movement. This made the modern car layout practical and reliable. But the Cardan joint had a flaw. It caused the output shaft to speed up and slow down slightly each revolution. At low speeds, it's unnoticeable, but at high speeds, it causes vibrations and stress. Still, the U-joint became a staple in millions of vehicles. It was a game changer, but not a perfect one. Engineers needed a smoother solution. The speed fluctuation from a single U-joint created vibrations and wear. The fix? Use two U-joints aligned so their speed variations cancel each other out. Most rear-wheel drive cars use this setup for smooth, constant rotation. In vehicles with steep angles, like 4x4s, a double Cardan joint, or constant velocity, CV joint, is used. This design cancels out speed fluctuations within the joint itself, even at sharp angles. Engineers also added rubber dampers to absorb shocks and further reduce vibrations. The goal: make the drive shaft so smooth, you never notice it. Precision balancing and clever engineering made this possible. The pursuit of smoothness drove constant innovation. The drive shaft became invisible to the driver, just as it should be. Front-wheel drive changed everything. Now, the drive shafts, called half shafts, had to transmit power while steering and moving with the suspension. Standard U-joints couldn't handle the sharp angles. They caused vibrations and torque steer. Enter the constant velocity, CV joint, especially the Rosetta joint. Its ball and groove design keeps the output spinning at the same speed as the input, no matter the angle. On the inboard side, a tripod joint allows the shaft to change length as the suspension moves. These joints work together, protected by rubber boots filled with grease. If you see a torn, greasy boot on a front axle, that's a failing CV joint. CV joints made front-wheel drive practical, smooth, and reliable. They're now found on nearly every modern car. The drive shaft's evolution continued. For decades, drive shafts were made almost exclusively of steel. Strong, affordable, and easy to manufacture, but undeniably heavy. This weight was a necessary compromise in the early days of automotive engineering, as steel provided the durability needed to handle the torque and stress of powerful engines. As automotive technology advanced, high-performance cars demanded lighter, faster spinning shafts to improve acceleration and handling. Reducing weight became crucial for both speed and efficiency. Aluminum offered a step forward, lighter than steel, yet still strong. But the real revolution came with carbon fiber. This material is just as strong as steel, but up to 70% lighter, transforming performance and efficiency in both racing and road cars. Carbon fiber doesn't just save weight, it also dampens vibrations, making rides smoother and quieter. In a crash, it shreds safely instead of flailing dangerously, reducing the risk of injury and damage. With the rise of electric vehicles, some predicted the end of the drive shaft altogether. After all, why not put a motor in each wheel and eliminate the need for a central shaft? But hub motors come with their own challenges. They add unsprung weight to the wheels, which can hurt ride quality and handling, and they must endure harsh road conditions, making them less practical for many vehicles. That's why most electric vehicles still rely on drive shafts or half shafts to deliver power from a central motor to the wheels, balancing efficiency, reliability, and performance. The drive shaft endures, evolving from a simple iron rod to today's high-tech carbon fiber marvels. Its design has changed, but its purpose remains vital. Its job remains the same, quietly and reliably connecting power to motion, hidden beneath the car but essential to every journey. For over a century, the drive shaft has solved the complex problem of linking a fixed engine or motor to moving wheels, adapting to every new automotive era. It's a testament to practical engineering, a true unsung hero that keeps our vehicles moving, often without us even noticing. Next time you drive, take a moment to remember the spinning shaft beneath you, working tirelessly with every mile. The drive shaft, still spinning, still essential, and still at the heart of automotive innovation,